In this chapter 3, we'll be discussing the competitive market and how it's described by the supply and demand model. We'll look at what exactly is a demand curve and what is a supply curve. And one of the key distinctions is the difference between a movement along a curve and shifts of that curve. In fact, that's a very important difference and a pitfall that many students have a difficulty with. And so I'm alerting you up front here that that's one of the issues with this material, is to distinguish between a movement along a curve and a shift in the curve. And then we'll talk about equilibrium and how the interaction between supply and demand curves determine equilibrium price and equilibrium quantity. And finally, we'll talk about shortage and surplus. When the price is not at equilibrium, a shortage or a surplus is created, and how does that price move back to equilibrium? Remember, we talked about shortage as opposed to resource scarcity in Chapter 1, and here we're going to actually provide the details behind the distinction between shortage and resource scarcity. So a competitive market has lots of buyers, many sellers, and the good that they're buying and selling is homogeneous. That is, it's the same. There's almost no distinction among the different units of the good. You can't say that about cars, for example. When you sell a car, the car may have all kinds of different features. So goods that are feature-rich cannot be homogeneous or the same. That's why competitive markets fit commodities like corn well. They fit commodities like wheat well. Local flower markets, farmers markets, where you walk down the street and see many different little sellers selling tomatoes, for example, and you would expect to see the price be very similar across those tomatoes. That's the kind of market we're describing now. Supply and demand model is the model that allows us to talk about how that market behaves. So demand represents the behavior of buyers, right? A buyer is someone who's purchasing something in the marketplace. The demand curve shows the quantity demanded at various prices, so there'll be an actual quantity associated with each price. And that quantity demanded is the quantity that buyers are willing and able to purchase at any given price along that demand curve. So you might be able to ask, why did this elderly, maybe retired gentleman decide to buy a Razor scooter? Maybe he did so because the price fell enough to where he thought he'd try it and buy it. So a demand schedule is going to be a table, and the associated demand curve is the graph. So here's the schedule here. So you imagine that for each price, here $2, there's a quantity, in this case 7.1 billion pounds of cotton demanded. And so notice that as we lower the price, the quantities get larger. At $1.75 per pound, 7.5 billion pounds are demanded, and so forth, all the way down to where we get to 50 cents, 14.2 billion pounds of cotton are demanded per year, perhaps. And the connection of all those dots creates a demand curve. And as the price falls, the quantity demanded rises. That is basically the law of demand being shown in graphical form there. One of the things that you want to be careful of, as I mentioned earlier, is that a change in demand is not the same thing as a change in quantity demanded. And this is going to be something that will confound you if you don't kind of get a handle on it early on. And so let's talk more about that. A change in demand, then, is occurring in this fashion. Suppose there's an increase in the entire demand curve, meaning that there's an entirely new schedule. At every price in that schedule, there's now a higher quantity demanded. The one we're showing is the $1 price, and that has a 15 billion pound quantity associated with it, whereas previously it had a 10 billion pound quantity associated with it. But that's true at every price along there. If you notice, the parallel shift of the demand curve means that at every price there's going to be an increase of 5 billion pounds. Now, contrast that with a change in quantity demanded. So if we start at the same dollar price and 10 billion units demanded, and if we lower the price, notice we didn't do that in the left-hand panel. We simply had some story about an increase in the quantity demanded at every price. But here we have a price falling itself to 50 cents. Notice that you fall along the demand curve and the quantity grows to 14.2. So you move down and along the demand curve and the quantity demanded increases to 14.2 as a result of the price decrease itself. So there, the two red arrows show you the exact difference between a change in demand, which is the entire schedule shifting, and a change in quantity demanded. You have to have a handle on that. So the law of demand says that a higher price for a good or service leads people to demand a smaller quantity. Now let's look at a decrease in demand. That would be a leftward shift. Now, Krugman alternates between a linear demand curve, straight line, and a curved demand curve. No problem, we can handle either one, so don't worry about that. What are the two kind of chicken feet scratches down there below? Well, those are ways of showing that we've not scaled the entire range of quantities from zero to some large quantity, or prices from zero onto some higher price. In fact, we're cutting off the diagram there. That's what that says. So you notice that you can see that the 7, if 8 is that far to the right of 7, then obviously we don't have enough room to the left to have accounted for everything from 0 to 7. So we've basically truncated the scale there. And we've done the same thing down below. Okay? And so basically, here's a decrease in demand, which calls for a leftward shift. Okay? And that means that there's a lower willingness to pay for the same quantity, so that's the downward arrow. But there's also less quantity demanded at the same price. Either way is a fine way of describing that, but you need to be aware that that leftward shift involves less quantity demanded at the same price. An increase in demand is a rightward shift, right? And so there's a greater willingness to pay for the same quantity. That is at 10 units. Consumers are now willing to pay $2 rather than $1. And there's also a greater quantity demanded at the same price. So at the $1 price, people now want 15 units rather than 10. So that's the description then of an increase in demand. What are some of the demand shifters? What variables then would cause demand to shift either direction? Well, there's 5 categories. One is the change in the prices of related goods or services. And we'll talk more about what those are in just a minute. But other goods and services that are related to this particular good we're talking about and changes in those prices of those goods can cause the demand to shift for the good that we're modeling. Changes in income, of course, because that is what determines the consumer's ability to purchase a good or service. Changes in tastes. We don't spend a lot of time with this because we tend to think these change rather slowly. But of course, taste can change over time. And they may have changed relatively quickly in the face of COVID-19. Changes in expectations. If we expect a price to be higher next period, then we might buy more this period. We might speed up our purchases, for example. And finally, the number of consumers, the number of buyers in the marketplace. Those are all important demand shifters. So you need to be able to shift the demand curve appropriately for changes in these. And by changes, we mean either right or left, either increases or decreases, right? So you have to come up with the correct shift of the curve for the stories that are going to be told around these kinds of variables. And we'll do lots of practice on that. By the way, these shifters are also shown in two JPEGs that are loaded under the resource section of Chapter 3. So let's look at the change in price of related goods, in particular substitutes. If you're traveling to Hawaii, and people have probably actually explicitly thought of this, individuals have, although we could trace this in the market. But I know people who think about Hawaii or Mexico. Not so sure. They're thinking them as substitutes. There's other people who say, I would never go to Hawaii, I always go to Mexico, and vice versa. But to a large degree, that's going to depend in some ways on the price. What happens to the demand for travel in Hawaii if the perceived safety cost, now we're not talking about the cost of the vacation itself, but the perceived safety cost of traveling to Mexico increases? What happens to the demand for travel to Hawaii? Well, it probably rises, right? So these two goods are substitutes. And if a decrease in the price of one leads to a decrease in the demand for the other, or in the opposite direction, then these goods are substitutes. Likewise, if an increase in the price of one leads to an increase in the demand for the other, then consumers are clearly getting out of the one that's more expensive and demanding more of the one that's relatively less expensive. So those are substitutes. Complements. Goods are complements typically when they're used together. They're purchased together. Classic example is skis and bindings. Right? If the demand for skis rises, you expect the demand for bindings to rise as well, or the demand for snowboards, for example. So if a decrease in the price of one good leads to an increase in the demand for the other, so for example, if the price of skis drops, and now we have an increased demand in bindings, that's because we're buying more bindings along with purchasing more skis, right? So the complementary relationship of those skis and bindings is clear. They're often bought together. Skis and bindings, peanut butter and jelly, what have you. Now you may say that that's not a compliment for me. It doesn't have to be, but in the market we tend to see it. It may not be true for every individual. But there are a lot of goods that are very strong complements for many people. And an example would be gasoline and SUVs. If an increase in the price of gasoline will decrease the demand for SUVs because they're used together, I think. Those are complements. Changes in income. If an income increase occurs, then the effect on the demand curve depends on whether the good is one of these types, and that is a normal good, so demand increases when income increases. Restaurant meals out might be a good example. You've got more money, you tend to eat out more often. But if it's an inferior good, which doesn't mean quality, but means just that specifically demand decreases when income rises. Maybe that's a bowl of ramen there, and maybe you eat top ramen as a student. But when you come out with that econ degree and get that first job, are you really going to tell me that you're going to be eating just as much ramen as before? You might initially because you developed a taste for it, but eventually ramen will probably fade from your consumption portfolio. And that's because it's an inferior good. It's something whose demand decreases when income increases. But tastes are also subject and vary among consumers, as do preferences. For example, they can be seasonal, or they can be fad-like, and those have fairly predictable effects on demand. Boots are more heavily demanded in the fall, for example, in October, when it's time for pumpkin spice lattes and boots, as my daughter tells me. Changes in expectations. If consumers have a choice about the timing of a purchase, they may buy according to those expectations. They probably will buy according to those expectations. So if prices for Xbox 360 consoles are expected to be lower right before Christmas, then who's going to buy in November? And sales of those, purchases of those Xbox 360 consoles will probably drop in November and then rise in Christmas when the price is expected to be lower. So here's a learning by doing question, and I actually gave you the answer there. When the price of petroleum goes up, the demand for natural gas does what? The demand for coal does what? And the demand for solar power does what? So assume that they're all substitutes for petroleum. Each of these are just energy sources and substitutes. That means that if they're substitutes, if the price of one good goes up, then the demand for the other three substitutes must also rise as well. So the correct answer is A, increases, 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 because these are all substitutes. Changes in the number of consumers. What happens to diapers demand in Russia as these birth rates are dropping quite dramatically, as it turns out? Demand for diapers is falling, so that population matters, the number of consumers matters, affects the position of the demand curve. Which of the following will cause an increase in the demand for cars? The price of car tires increases because of the Malaysian rubber shortage. Concrete steel reinforcing rods are replaced by aluminum along the Atlantic coast to prevent rusting. Gasoline prices drop by 50% when OPEC nations increase production, or McDonald's increases its hamburger production in response to consumer trends. Well, the first one's actually can affect the supply side. But in fact, the most direct effect here, of course, is the gasoline prices dropping by 50%. And that's a complement to car travel, to buying a car. So the demand for autos will increase in response to much cheaper gas. So answer C is our best there. Now, how do we get from an individual demand curve to a market demand curve? And just as a simple example of two individuals. Here's Darla. That's her individual demand curve for blue jeans per year, quantity of blue jeans per year, and then price of blue jeans per pair, it should say up there. It should say per year down below. So she buys, 20 to 30 depending on the price. Dino's individual demand curve is he buys 10 to 20 depending on the price. And we add those together. So we're going to keep the prices at 1 and 2, but we're going to add Darla's and Dino's individual quantities demanded, 20 plus 10 at a price of 2, and 30 plus 20 at a price of 1 to get the market demand curve. So you see at $2 now there are 30 units consumed across Darla and Dino, and 50 units consumed when the price drops to $1. That's simply how we construct a market demand curve, simply by horizontally summing the quantities at each price. Well, let's begin talking about supply now, the other side of the market. Supply is the behavior of sellers. It's going to represent that. And a supply curve shows the quantity supplied at a variety of prices. The quantity supplied itself is the quantity that producers are willing and able to sell at a particular price. And so that you notice that language just exactly matches the language of quantity demanded, demand curve, and so forth. And that's intentional, of course. So here is a supply schedule. On the right, the schedule is the table of price and quantity values. Notice that as we move from 50 cents to $2, the quantity of cotton supplied in billions of pounds rises. That is the law of supply. Otherwise, everything else equal, ceteris paribus, that is, an increase in the price causes suppliers to produce more quantity. And we're seeing that along that supply curve. So what about an increase in supply? An increase in supply involves a rightward shift. A movement along the supply curve would not be the same thing as a increase or shift in the supply curve. And so this rightward shift in the supply curve is not the same thing as a movement along the supply curve. The only thing that causes a movement along either the supply or demand curve is the price itself, the price that's featured on the vertical axis there. Everything else, every other variable, is going to cause the supply curve to shift or the demand curve to shift. Here's a shift of the supply curve. Rightward means increase in supply. So there's more quantity supplied at every price, right? And that's a rightward shift. A decrease in supply means a leftward shift. A leftward shift. So what are the supply shifters? These are the main variables that would shift supply, just like there were some 5 shifters for demand. What are they? Input prices, right? Wages to workers, salaries, the prices of related goods or services. So there again, there's a related goods kind of rationale for shifting the supply curve as well. We'll talk more about that. Technology, how well do we produce? How good is our technology in terms of its ability to produce the good or service? If it improves, then the supply curve shifts to the right. Think about it. If it worsens, the supply curve would shift to the left, logically. In our day and age, there's not too many opportunities to talk about technology worsening. So that's not a story we tell very often, but it can be told historically in certain time periods. It can be told. Expectations. Okay? If you expect to see a price increase for corn next quarter, and corn is storable, that's important, then you'll probably withhold sales now and sell them in the next period, next quarter. And then, of course, the number of producers is also going to shift the supply curve. Let's look at a decrease in the price of an input. And that's everything else equal. Everything else is the same, but say wages fell. So that increases your profits, right? Because if everything else is equal, that means you've got the same price and the same cost structure for all of your other inputs, but one input's price fell, wages maybe. That's going to encourage you to expand supply because you're more profitable in doing so. So what will happen to the number of new businesses if the government reduces the fees and red tape associated with new businesses? What happens if the fees rise? So if the government reduces those fees, this is a major claim of the Trump administration, of course, as to why the economy was stimulated and the rate of business formation increased, was through the removal of fees and red tape. If that's true, then we expect the supply curve to shift to the right. So when the price of cotton drops, what happens to the supply of blue jeans? Notice you're in the market for blue jeans here, but you're looking at an inputs price. Cotton is a key material input for making blue jeans. If the price of that key material input drops, you should be able to supply more blue jeans at any price, and that's an increase in supply. Well, inputs used in production have opportunity costs, don't they? Sellers will choose to use inputs whose profit is the highest. So now looking at changes in the price of related goods or services, sellers will supply less of a good if its profitability falls, and so there are substitutes and complements in production as well. What's a complement in pork processing? Well, that would be lard, would be a good example. Diesel and oil production tend to be complements in production. Substitute in corn production is cotton. You can use your land for producing cotton rather than corn, or soybeans, for example. There's an article in this particular chapter's discussion articles on the food fight between soybeans and corn. Well, that's simply related to this very concept here, that farmers will plant that which they think is most profitable, and they may switch from year to year, not that often probably, but they'll switch every once in a while between corn and soybeans because they're substitutes in production. New, improved technologies make sellers willing to offer more at a given price or sell their quantity at a lower price. So that's also a rightward shift of the supply curve. The technological innovation lowers costs and increases supply. What about expectations? If you expect a higher price for a good in the future, that means you're going to sell less now and store the good until you can sell it at the higher price. Okay. And changes in expectations, for example, as producers expect sales and profitability to increase, then windmill production increases. If you expect the profit, maybe perhaps that's because of some government program that's subsidizing the consumption of renewable energy, for example. And changes in the number of producers. If you just simply have more producers entering and exiting the market, key terms there, by the way, entering and exiting, those will come up again in Chapter 13 on the perfectly competitive model, then the overall supply is going to change, isn't it? With more producers, the supply curve will shift to the right. With fewer producers, the supply curve will shift to the left. Okay. How about the individual supply curves for coffee here? Mr. Silva and Mr. Liu, 2 and 3 pounds of coffee beans being supplied at prices of $1 and 2 for Mr. Silva. For Mr. Liu, it's 1 and 2 pounds of coffee being supplied per period here. How does that look in a market supply curve? Well, we simply, again, sum the quantities at each price. So notice we keep the prices of 1 and 2 constant, but now we add the 2 and the 1 pounds at the $1 price to get 3 pounds, and the 3 and the 2 pounds at the $2 price to get 5 pounds, and that becomes the market supply curve. Now, with hundreds, if not thousands, of maybe even millions, probably not millions, but thousands of suppliers, you can imagine that this gets fairly complicated, but the principles are the same.